both the brain through tryptophan depletion and mitochondria through the way that viruses attack. If you want to study that in depth, there's something called the cell danger response. It really gets into depth on that. But the cell danger response shows how mitochondria in the presence of a viral infection start to do some pretty crazy stuff. Okay, they start to generate a lot of oxidative stress and cause a lot of dysfunction in the body. So here again, we have pro-inflammatory cytokines, tryptophan, kynurenine, and we're measuring all this stuff, kynurenic acid or kynurenate. We're testing that, and we're testing for tryptophan. So you're going to be seeing on the labs, if tryptophan levels are low or kynurenic acid is high, you've got a problem potentially here, right? If kynurenic acid or kynurenate is high, that's going to mean that there's inflammation in the body, which is depleting your tryptophan. You see that on the labs. And then, of course, you want to reverse that. There's also another one. Oops, sorry, hit the wrong button there. There's also another one you really got to know here, which is called quinolinic acid. So if you get enough inflammatory cytokines going, the kynurenine pathway gets activated, kynurenic acid goes up, and eventually you'll have high levels of quinolinic acid also. Okay, and that is a neurotoxin. Not good. Damages the brain. We're testing quinolinic acid, and the correction here is obviously to stop the cytokines thing from happening. So when you see inflammation in the body, one of the main ways, if not the main way, that we stop that inflammation from being a problem is by making glutathione.